Okay, differential equations 5.1, we've got day 5. And on the last video, we actually had found our characteristic solution. We also found our particular solution. So that means that we can actually say that x is equal to x sub c plus x sub p. And as we put that all together, we'd have c1 cosine of omega t plus c2 sine of omega t. And then, of course, we're going to add our particular f naught all over omega squared minus gamma squared times the sine of gamma t. And this can be well and good, and we can definitely feel confident that we've gotten quite far. But remember, this is an initial value differential equation, in that we're given that our initial position is 0. At t equals 0, our position is 0. We can, right now, plug in our t of 0. Now, the cosine of 0, of course, is just going to be a 1. The sine of 0 is 0. So for both the sine of omega t and the sine of gamma t, those terms are going to completely wipe out, and delightfully, we're going to know that c1 is equal to 0. That means that in this original form, we're able to exclude the cosine of omega t. That's dropping out. It's dropping out immediately. And right now, we just have to, in this particular situation, find out what C2 really is. We're going to have to also use the initial condition that x prime of 0 is equal to 0. So let's do that. Let's take our derivative. We'll have x prime, and the derivative of sine, of course, is cosine. So we'll have, with the chain rule, C2 omega. And then we'll have the cosine of omega t. And then we'll have the derivative of sine, of course, is cosine, but this time we'll have a gamma come out from the chain rule. And once again, here we'll have a cosine of gamma t. And very nicely, when we plug in the 0 for t, we already know that the cosine of 0 is 1, so we've got C2 omega. Right here, this is going to go to 1 also, so we'll have f naught, there's gamma, all over omega squared minus gamma squared. And wow, we're just going to have to solve for C2. So tell you what, we can actually subtract this f naught gamma all over omega squared minus gamma squared. And then finally just divide by that omega. And wonderfully, as we put that additional omega in the denominator, you can see where we are. Now, this was our original solution once we threw in that c sub 1 was 0. So as we just finished this up wonderfully, we can now say, now that I know what C2 is, we can say x is equal to the opposite of f sub 0 gamma all over omega squared minus gamma squared sine of omega t plus f sub 0 all over omega squared minus gamma squared sine of gamma t. And that is it for that problem.